Hi, I'm Ms. Hearn. Let's get started. In previous videos, we talked about walks, paths, and trails, as well as circuits. And in this video, we're going to talk about a special category of trails and circuits called Euler trails and circuits, which have a special characteristic that they visit every edge of the graph at least once. If you find this video helpful, please give it a thumbs up. That will help other students to find the video. You can also subscribe to my channel, Ms. Hearn Mathematics, for more graph theory and other mathematics videos. So first, let's recall what a trail is. And remember that different graph theory books use different terminology. So you really have to pay attention to the definition. So in your book, they may refer to a trail as a path or another term, but a trail, as in this video, is referring to any walk through the graph with no repeated edges. When I say Euler trail, I'm adding the condition that it visits every edge. So if you think about it, if it has no repeated edges, but it visits every edge, this means that an Euler trail visits each edge exactly once. And to help you remember that, think of the E in Euler as meaning every edge. Now you might also remember that a circuit is a closed trail. In other words, it's a trail that begins and ends at the same vertex. So an Euler circuit is just a closed trail that uses every edge of the graph exactly once, because trails only visit each edge once. So is the sequence A to E to B to A to D to C to B to D an Euler trail? Does it have the characteristics of a trail, meaning it is a walk with no repeated edges, but does it visit every edge once? So in other words, we're looking for a walk that visits every edge exactly once. So from A to E would be this edge. From E to B would put us here. From B back to A would go this way. From A to D would put us here. D to C would cover that edge, and C to B would cover this edge, and B to D would cover this edge. It is a walk. It stayed on the graph. It hit every edge, and it only hit each edge once. So yes, this would be an example of an Euler trail. Do you think that this would be an example of an Euler circuit? A to B to C to D to E to F to A. Let's check. So I'm going to trace this out on my graph. So I'm going to start at A and go to B, and then I'm going to go to C, and then I'm going to go to D, and then I'm going to go to E, and then I'm going to go to F, and then I'm going to go back to A. So this is definitely a circuit because it doesn't visit any edge twice, but it's not an Euler circuit. Why is it not an Euler circuit? Because Euler circuits have to visit every single edge, and we missed the edges BD, FB, and DF. Now you try. We're going to determine which of these sequences show Euler circuits. If you want, you can pause the video and work on part A, and then press play when you think you have the answer. So for part A, we're going from V to W, and then we're going from W to Z, and then we're going from Z to Y, and then from Y to V, and then it appears we're starting over again. We're going to go from V to W again, and then W to Z, and then Z to Y, and then we're going to go over to V. So what does this tell us? Well, we have repeated edges, which means that it's not a trail, which means that it's not a closed trail or circuit, so it can't be an Euler circuit. If it's not a circuit, it definitely can't be a special kind of circuit. All right, how about part B? You can pause the video if you want to and give it a shot, and then press play when you think you have the answer. Okay, so in part B, we're going to go from Z to W, and then from W to V, and then from V to Y, and then from Y to Z. All right, so this definitely is a trail because there are no repeated edges. It's a circuit because it's a trail that begins and ends at the same position, and it visits every edge, which makes it Euler. So B is an Euler circuit. All right, try part C. Go ahead and pause the video and press play when you have the answer. All right, so for part C, you can observe that we go from V to W and then from W to Y. And you can actually stop right there because we have a problem. WY is not an edge, so this isn't even a walk, much less a trail or a circuit or an Euler circuit. In order to be any of those things, it has to stay on the graph. All right, let's do one more. Again, if you'd like, you can pause the video and press play when you have your answer. All right, so for part D, we're going to go from V to Y, and then from Y to Z, and then from Z to W. All right, well, we have a couple of problems here. This doesn't visit every edge, and it doesn't begin and end at the same place, so it's not a circuit at all, so it can't be an Euler circuit. So remember, an Euler trail in a graph is a trail, so it doesn't repeat any edges, and it visits every edge of the graph exactly once. An Euler circuit in a graph is a circuit or closed trail, so it begins and ends at the same vertex, and it uses every edge of the graph exactly once. In the next video, we're going to talk about how you can tell if an Euler circuit exists in a graph. I hope you found this video helpful. If you did, please give it a thumbs up. That helps other students to find the video. You can also subscribe to my channel, Miss Hearn Mathematics, for more graph theory and other kinds of math videos.